Yeah, I think we can all relate to the domain of healthcare, and that's also what makes this so nice to work on this product. Actually, everyone you talk to has at least someone they know that had an operation, a surgery, or had a surgery themselves. And actually, unfortunately, in some cases, this can lead to an infection, quite a number of cases, but I'll go in more depth later. We found out this morning that we forgot to update the outline, so I'll just give you a very short recap. We have two sections of the talk. So the first section is me talking about the higher level overview of what we've done and basically the problem we're trying to solve with our product. And then Laurens will take over, and he knows a lot more about the machine learning models behind it. So he will go more in depth on the models and also the performance of those models. So yeah, we're also talking about challenges, and as you can see, this is the timeline of Healtphlus.ai. The company was founded in 2017 with 4 people. I entered the company, I think, around 2021. And we've basically explored AI solutions in healthcare. So we've looked at all these different sort of models that we could develop to make an impact on healthcare. The company arose out of frustration of our founder. He's a doctor. Oh, I didn't do anything. Yeah. That's probably AI as well, I don't know. He saw that most things in healthcare, they're very reactive. So someone gets sick and then you start treating. Well, actually, you want to be more on the preventive or the proactive side. We're not saying we're preventive, but we try to be in the more proactive side. So we want to help doctors make decisions that could actually benefit the outcome of the patient. So we started in 2017, explored a couple of different options. Then in 2021, basically zoomed in on infection prediction and did a proof of concept at the Leiden University Medical Center. We secured some funding to actually grow the team to about 12 people. We entered the world of CE certification, and I'll talk more about that in the next slides. And then we're at the moment at the point of looking at our second stage audit, so all the way in December, which would be the final point for certification. After that, it's still 3 to 9 months until we actually may hit the market. So we're only allowed to do things in the market once we get certified, which is, I think, a good thing. So the problem, we see that 17 to 25% of the surgical patients, they get an infection after surgery, which is, of course, first of all, for the patient itself, it's a super bad thing. So think about the pain that is also combined with the infection. At the same time, and we're a commercial company, it's also a cost impact on healthcare, basically. I don't have the numbers by heart, but there's millions of extra costs because patients get an infection, have to be readmitted to the hospital and treated to the hospital. So we're very bad also at detecting infections early on. So we only realize it after a couple of days that something is wrong with the patient. At the same time, we know that in healthcare there's plenty of data. There's all these, like most hospitals in Europe, they have electronic health record systems. So every little bit of data is stored from a patient. So vital signs, lab results, all these data points, they're actually there. But we only use a very little amount of that to actually add value. We have a shortage in health workers, so there's a lot of people working in healthcare, but not enough to treat all the patients, to give all the patients the attention that they need. And at the same time, expenses of the healthcare system, they increase steadily over the years. So that's another thing. Oh, that's good. Well, it can read my mind. So what do we do to solve this? We've made a medical decision support system. So what we do is we look at the data that's already in the EHR, so in the electronic health record system, and then we see if we can predict the risk of an infection of a patient after a surgery. So we do that by just integrating within the workflow of the clinician, so we're directly integrated in that EHR system. We also offer a additional view, so it's not just a prediction, but we offer a consolidated view on the data that's present. So we try to bring all the information that the clinician needs to decide on what to do after an infection has been diagnosed. We bring that to one single screen in the EHR system. So what does it look like? We have this infection dashboard, which is our main overview. You see on the left side the infection. We predict for the probability of an infection within 7 days and within 30 days. We connect it to a risk score, so high, medium, or low. And on the right side, you see all the vital parameters, the lab results, the lines, for example, that a patient has received. The extra thing we do, so for explainability, we also talk about the predictive factors. So we show the predictive factors that contributed to that infection prediction. Some of the challenges, I've already said it during the coffee break to some people, like getting data was one of the main obstacles we face. And of course, you can imagine privacy is pretty stringent. So it took quite a lot of time to actually get data to base our development on. Then data is not standardized, so we have all these EHR systems. There's a couple of vendors. There's actually one vendor that's almost that's dominant in the Netherlands, has the biggest market share. But still, every hospital can do their own sort of additions to the data structure, and mostly also the content of the data. So they have different coding schemas, etc. So it's not really standardized. The structure of the database usually is, but the content definitely not. And then the CE certification part. So we're a small company, like I said, 12 people at the moment. We can only actually implement our product in the market once it is CE certified. So we have to prove in a very elaborate way that we're safe to use. That's the main goal of that certification. And this is easily a 2-year process. So going a little bit more on the architecture. So what does it look like? We have an EHR system. We have an ETL process that's still hospital specific. We extract the data. We send it, we push it actually into our solution, which is called PERISCOPE. And then we process the data. We generate the dashboard out of that and finally present it through the EHR system back to the end users. Going a little bit into our development strategy, we have a strategic partnership with SAS, but we've set also we work with a lot of data scientists, data engineers. We want to make our development flow basically all in Python. So we have an open source development core, and what we do is we actually convert that to SAS to have our first version of the product. And at the next year, so in 2024, we're also planning to do a Python-only version of our product. So we actually formalize the Python code that we already wrote in that development stage. As you can see, all sorts of nice open source packages that we can actually use there. And then, Laurens, you can brief us a bit more on the models?
Yeah. So, can I get a reading of who you are? Who of you are data scientists and working on developing models? Okay, and so the surprise for me always is that if your model is done and you're satisfied, then you don't have a product yet, right? Bart showed us our interface. But this is the model output. This is the number that I've been working on. But this is what our users will be using. So that's a huge difference. But I will tell you how I got to this number. And to get that, we used, of course, supervised machine learning. And to use supervised machine learning, you need a label. You need a ground truth. And the first year of our product development was getting that ground truth narrowed down. Because you have these EHR systems in the hospital, and Bart told you everything is registered. Observations, notes from medical staff with the patients, but it's all free text. And there's registration systems like complication registrations. But it's not complete. For instance, so what you see here is a pie chart of patients after surgery, and the green circle, it's the amount of patients for whom infection is registered. But I can't see the colors. The red circle, it represents all the patients that have been prescribed antibiotics after surgery. And you only get prescribed antibiotics if you have an infection, if there's a strong suspicion that you have an infection. So we should consider these patients to also have an infection. And there's also a small part of patients that actually go back into surgery after their primary surgery to get some infection treatment, for instance, for wound cleaning, or for orthopedics there are some more intensive follow-ups, but let's not get too visual, but so we've spent a lot of time debating or discussing with different physicians from the hospitals with whom we've been cooperating on how do we pinpoint the patients that actually do have an infection, and eventually we decided to take this whole population. So if you have infection registered, or if you have been given antibiotics, or if you have gone back to surgery, we will consider all these events as a positive label. And all the other patients, so for whom this does not occur, that's the negative population, and that brings us to an incident rate of about 10%. So that's what we are working with. So then Bart told you about how diverse the data is. Of course, here in the Netherlands we have two large suppliers for EHR systems. It's Chipsoft and it's Epic. But with our MDR certification, we will be able to supply hospitals in the whole of Europe. So it's a diverse field. So what we've been building is a data loading part, where there's a hospital-specific part that does ETL and transforms the hospital data into a uniform set of tables from which we can then build a feature matrix on which we can train our models. And we've tried to separate different stages in this ETL process. So first we will start with the data in tables as the hospital supplies it to us, and we will do a structure mapping to a structure that we know, so with a defined set of columns and a defined data types per column. So then we have data that we know and we can work with, but then there's a lot of knowledge that we still need to add. For instance, there's a condition registration, but it's a lot of really specific conditions, and like thousands of them represents infections, and another 100 represents pregnancies. And we need to be able to detect that. So currently, we have two medical specialists working with us who go with, if we are landing at a new customer, who will go through all these conditions and label all the conditions that signal infection, and label all the conditions that signal pregnancies. And that's for conditions, but it's also for observations and for procedures. So that's a lot of manual work. But when we've done that, we have a set of data that is really concrete and uniform, and then we can run our system, and we can easily train our model and then use it in PERISCOPE. So then you, of course, okay. So that is, and then how do we train our model? We've used tenfold cross-validation and a temporal validation with an 80-20 split, where we've chosen temporal split to show that we can actually learn from historical events to say something about the future, at least the more recent past, in this case, of course. And then within this validation set, we've also done a subgroup analysis, so that we identify for the different populations within that temporal validation set, that we perform equally well on each subgroup. This way we try to detect bias or prevent bias from happening. And this way also we report that our model is actually safe for use for an entire population, for a hospital, and for the different groups within that hospital. So yeah, we've done this now with the LUMC and with Radboud UMC in the Netherlands, and we're currently working on expanding this across the border with a hospital from Belgium and from Denmark. So I'm really excited to see that our approach. So for now, I'm working on data from this hospital, and it works just as well. So I'm excited to see that our approach actually works across the border. And then you're curious to what we managed to get as results. So I've cramped them up into one slide. Does everyone know what an AUC curve is? Yeah, and what a calibration curve is? Okay, so for us, as we are showing the percentage of infection chance, and we are asking our users to work with that, the accuracy and the precision, they're not that important, because we don't translate it to a 0 or 1, to a definite infection or a definite non-infection. So we are aiming to maximize the AUC in our model, and this is where we got to, which I'm very happy to see that the performance between the train set and the test set is really equal, so that suggests a pretty good externalizability. So these are the curves, and then the calibration curve, of course, is important if you want to show the outcome of our model as a percentage. So this, you see here that our lines are on the diagonal of the calibration curve. So we can say that if our model gives a 40% chance, actually 40% of the patients that get that outcome to develop an infection after surgery. So with this, so I told you currently we're yeah.
Yeah, just a short question about the bottom row.
Yeah. Oh yeah. Sorry. That's so. What we were also wondering is now we are doing this procedure per hospital, but it would be nice, of course, to work with a pre-trained model and start that in new hospitals. So what we've tested here is what if we have trained a model on the LMC data, Radboud data, and use it for the LMC population, and the other way around. And you see a significant drop in performance. So right now, we cannot use this approach yet, in our opinion. But you would hope that getting more hospitals with whom we can develop our product, we can narrow this down, and then maybe we don't need to calibrate our model at each new site.
Are there numbers to see what compares, what outcomes you get when you don't use your product, and it's just the decision making as is?
That's a study that we're. So your question is, how does this compare actually to not using the product, and do we actually provide an advantage for the hospital? So of course, as Bart told you, we don't have a CE certification yet, so our product is not being used. We are comparing right now our product to decision making as it is right now. What we cannot test yet is how does decision making right now with our product improve the outcome of patients or value for hospitals. Yeah. It will be because of the change in population, and each hospital has their own specialty, and then but it's also because when we think about data, we think about numbers, and we hope that a high temperature predicts an infection, for instance, in our case, or something in the blood pressure. But very often, I think a high-dimensional model, machine learning model, it will not pick up on the actual temperature readings, but the fact that the physician actually chose to read a temperature or to order a lab test. So there's, I think, a lot of decisions by healthcare practitioners that our models learn from. And these decisions differ per hospital. Each hospital has their own protocol and their own approach to healthcare. Yeah, so as I told you, we are now working on expanding more hospitals, especially across the border. But as we see us approaching market, there's 3 points that we are working on right now. So maintenance is key. We're working on building the software to monitor the performance while the model is being used, and also to monitor the data that's coming in while the model is being used. And we are now in contact with the EHR vendors to also actually make that seamless integration possible, to make the view that we have built, to make that available in the EHR system. And as I've told you, these mapping files, so the mapping from the hospital-specific conditions to the conditions the signals that we need, it's a lot of work. So we will also need to build tooling to speed this up, to speed this process up. So that's it for us. Yeah.
What kind of special tricks do you do? I can speak very loud. What kind of special tricks do you do for explainability towards the users?
So maybe it's not that special. We use the Shapley library, and we pick the top 10 predictors based on impact. And what we've consciously chosen is to not order them by magnitude of the impact, because you have to prevent this causality versus correlation effect, where you have to prevent healthcare practitioners from seeing this as the buttons on which to turn in order to change the outcome for the patient.
Thank you. So, as a commercial company, which you are, how difficult was it to get access to the EHR records to do these types of analysis, or under what conditions do you get access?
It was, I think, one of the main challenges we faced when starting the company. I wasn't involved at that stage, but I know it took about 2 years to get our first data set coming through. Also because of GDPR, of course, that got introduced about the same time. In terms of what to do, you have to prove that you can actually deal with this information in a secure way. So you have to, well, we're not 27001 certified yet, but we'll get that next year. But you have to show that you have your information security management system in place and that you do have certain controls implemented to deal with the data in a secure way. Also, our initial projects have all been research projects, so they're combined projects with the hospitals, and this helps a lot as well.
Oh, yeah. Thanks for the nice talk. I was wondering what you do with monitoring and especially updating. Especially, I think that might also affect your CE certification, right?
So maybe to get a CE certification, you have to write an extensive monitoring plan. So we will monitor the model outcome and detect drop in performance. But there's no live learning or something like that. So it might be, so right now, the temporal validation that we've used, it's 2 years. So right now we say that the model is valid for 2 years, and then you need to update it, and then you need to like redeploy it. That's the approach.
Again, thanks for the talk. I wanted to ask, did you experience resistance in the adoption of these smart solutions in the medical field? And if so, was it based on reasonable resistance, or was it mainly the habit of doing the same thing in the same way?
Also, I think that's a bit early to really give a full answer on that because, like Laurens and I said, we're not implemented yet, so we still have to go through the challenge of actually having it implemented with healthcare professionals. But we do see a lot of enthusiasm in the forefront, so let's say the early adopters in healthcare, about the model. So actually in this stage, we're already approached by hospitals that want to use our solution, which I think is a signal that also it's a hype. So I'm also very aware that this AI hype, especially after ChatGPT, we're really riding that wave. But at the same time, you do see like sincere interest from also medical specialists. But I have to say, those early adopters, they are a special kind of medical specialist, that they are prone to being interested in these kind of technologies. I'm sure we'll encounter people that put some resistance, and I think that can be expected. It's not something that I'm too worried about. But it is something that we have to definitely take care of. And that's also why, I mean, the explanatory factors, they're important, but also like the whole right side of the dashboard, it shows information that's already there, which is useful in that whole decision making. So hopefully that also lowers the threshold a little bit.
Also there's the work pressure. Also there's the work pressure in healthcare. So a lot of healthcare professionals, they're really looking for tools to lower the workload. The burden.
Yeah, thanks for the nice talk. I was wondering, how do you guys deal with like the free unstructured text structure? Because I've seen, I guess, like some mapping, you have like sections like BMI, and then you have like a number. But do you guys also use, for example, you have like history of patient illness where a doctor writes like a quick summary of what happened? How do you guys, deal with that, and how do you guys map that actually? That was kind of wondering.
Yeah, that's a very good question. We don't. We only use the structured data.
But there is hope.
But I would love to spend some time on that. Yeah.
That was the same
Okay.
question.
So you're now, if I understand correctly, the CE certification is on European level, right? Are there any other major blockers when you roll out your products to operate on a European level, or once you get that, it's go time?
You have to also deal with local regulations, of course, also in Europe. I mean, you have the EU laws, but the countries have their own local regulations. Besides the EU, Besides the EU, we're also looking at the US, of course, and there you have the FDA, which also has an approval kind of mechanism that we'll have to go through. So for Europe, we have to oblige to all of the local regulations, and that could be another bottleneck or challenge.
What's the reasoning for going first in Europe instead of in the US with the FDA? What's the...
We're based in Europe, so I think that's the main. But it's of course debatable what strategy you would choose. I know for an FDA approval, you need also data from the US to prove that you're safe. And actually, in the US, they have a different kind of business model. You have to pay a lot for that data, which is, I mean, as a starting company, it's probably too much for us. We do have a partnership now with a US hospital, which basically cut us a good deal on the data. So we're making steps there as well. Shall I?
So you said that the result seems to be very sensitive to the procedure used in the hospital. How are you going to ensure that this product is not going to change the procedure that is being done? If they see a number and they see, that's because I did the procedure like this, they might change the procedure. And then the model suddenly doesn't give the result anymore.
Yeah, so for one, we offer our users the prediction at the point after surgery, the moment after surgery, and we use all the data up until that point. So the data that goes into the model, it's not changed by what the physician sees and decides to do. But then the labeling process might. But the labeling process, it's not only on the registered conditions, as I've shown you, but also on the given care, the antibiotics, and so there might be a change, and we will be monitoring for it. And if it's there, we need to act upon it. But it might also be quite small. Because if there's an infection, it will be treated, and if there's no infection. So the danger that I see is that there's given antibiotics just because there might be an infection, which is, of course, more and more discouraged in Europe, but it differs per country how easy antibiotics is being prescribed. So we'll see if that happens. I would think, to be honest. So I see your point, and indeed we would retrain and pick up that signal, right? That would be the answer. It sounds to me like the data would improve, so I would be happy with more measurements. Yeah.
But I think when you get more than 10 questions, that means that the talk was a success. So thank you so much. Thanks a lot, Lawrence, and thanks a lot, Bart. Let's give him an applause. And yeah, that was